Olusegun. This is my phone number 08055384618 for further counseling and explanation. Thank you. You can visit me on the YouTube channel, Orekoya, Mathematics Physics Fundamentals. Thank you. Today we are going into what is called calculus, applications of integration in finding the equations of normal and tangent to curve. Again, we are taking calculus, applications of integration in finding the equations of normal and tangent to curve. Exercise. Now, the exercise says the differential coefficient of a curve passing through point O minus 4 is given by 4x plus 7. Find the equations of the number 1 tangent, number 2 normal to the curve at point O minus 4. Now, solution. Differential coefficients actually means dy dx. So that means we have been given dy dx to be 4x plus 7. dy dx also connotes the gradients, instantaneous gradients at a given point on the curve. Now, to find curve y, this is what we need to do. We can imagine that we cross multiply the x to this other side. So when you cross multiply the x, we have 4x plus 7 dx. Now, to be able to find our y, we have to integrate both sides. This is the integral sign. Now, integrating the y actually means y. Now, to integrate 4x plus 7, this is what we do. The power of x here is 1. So to integrate, we add another 1 to it. And whatever our result is, we divide this bit. This 7 that doesn't have x actually means x raised to power 0. This is what we do here. Because we have 1 here before, we are going to add another 1. We have it here. Then the results, 1 plus 1, we divide it. This 7 that doesn't have x, we put x raised to power 0. Now, we now add 1 again. Our result is 0 plus 1, we divide with it. Then we add a constant term, c. And the name of this constant term is called arbitrary constant, which we need to find. Now, adding this together, we have this and that. Now, our y is 2x squared plus 7x plus c. How do we find c? Since the curve y passes through the given point 0 minus 4, that means the value of x at that point is 0 and the value of y is minus 4. Substitute this value now inside this equation. We have this. From there, we get our arbitrary constant minus 4. Therefore, substituting minus 4 back to c, we have y is equal to 2x squared plus 7x minus 4. Now, to sketch the curve y, take point x0 and also take point 0y together with the turning point. And at turning point, we know that the y dx is what? 0. Let's first of all get the point at turning point. Now, since at turning point the y dx is equal to 0, that means 4x plus 7 that was given originally here must be equal to 0 at turning point. Now, from there we get the value of our y, making x subject of a formula. We get the value of our s to be minus 7 over 4, which is as minus 1.75, approximately minus 2 in that place. Now, so at turning point, since our x is minus 1.75, when we substitute inside this value for x in our original equation, we discover that the value of y at turning point is minus 10. So at turning point, our x is approximately minus 2 and our y is approximately minus 10. Now, we want to find the other point we need to construct our curve, the point x0. Now, taking point x0, that means the value of y is 0. Substituting y to be 0 in the original equation of y, we discover that 2x squared plus 7x minus 4 is equal to 0. This is a quadratic function. Now, we need to factorize the quadratic function in order to get what is called the root of our quadratic equation. Now, we multiply the coefficient of x squared, which is 2, by the constant term minus 4. This gives us minus 8. Now, we think of a number that when we multiply them together, will give us minus 8. When we add them together, will give us minus 8. We discovered that plus 8 times minus 1 will give us minus 8. Plus 8 minus 1 will give us plus 8. Substituting plus 8 minus 1 to plus 7x here, we have it there. Now, opening this bracket, we have this arrangement. Factorizing 2x out, we have this. And factorizing minus 1 out, we have that. Now, in a nutshell, the factorization of this quadratic equation gives us this factor. Now, to get the root of our equation, we express x as subject of a formula in each case. So in this particular place we have here, 2x minus 1 is equal to 0. That's where we have here x plus 4 is equal to 0, because we know that 0 times 0 is equal to 0. Therefore, each of these, either this one is 0 or this one is 0. So we have this expression. In a nutshell, our x in each case is half and minus 4. So what we are trying to say is that for the first point x0, the value of our x can either be half or minus 4. At that point, the value of y is always 0. Now, for the second point, 0y. At this place, our x is 0, so we substitute 0 to the value of x in the original equation. We discover that our y is minus 4. So now, point x0 and 0y, we have half 0 and minus 4 0. And at turning point, we have 0 and minus 4. Now, to sketch the curve, we use the derived point above and the turning point. And then at our turning point that we got the other time, we discovered that the value of our y is minus 2 and the value of our x is minus 10. So we plot the turning point minus 2 and minus 10. This is minus 2 when the value of y is minus 10. When we plot it, our turning point for this curve is this. Then when we plot the root of the equation in which x is half and x is minus 4, at which y is 0 in each case, we have this point. Now, when the intercept also on a y-axis, how do we get it? On the y-axis, the value of x is 0, and when we substitute x into the original equation, we discover that our y is minus 4. So we now plot this point. We have this curve. Now, we want to get the equation of the tangent and normal to this curve at the point 0 and minus 4. This is what we have here. To construct our equation, we write the expression for the gradient for tangent and the gradient for normal line. The tangent and normal line, they are at angle 90 degrees to each other. Now, the tangent gradient, which is mt, is y2 minus y1 over s2 minus s1. In this case, our y2 is y and our y1 is minus 4. Our s2 is x and our s1 is 0. Substitute that in this one, we have the gradient of the tangent to be y plus 4 over x. But the gradient of the tangent is the same thing as the gradient of the curve at that same point. And the area of the point of the curve at that point is dy dx. Now, taking our dy dx, which is 4x plus 7, at points when x is 0, we substitute it. We discover that our dy dx is 7. Therefore, the gradient of the tangent is 7. Plus multiplying, we have this as the equation of the tangent. Now, to obtain the equation of the normal, there is a relationship between the gradient nt of the tangent and the gradient of the normal. And that means the product of the gradient of the tangent and the normal equal to minus 1. That's what we have here. Mn mt must equal to minus 1. Now, since our mt is 7, we substitute mn is 7 is equal to minus 1. But mn2, the equation of this normal, in which y2 is y and y1 is minus 1, x2 is x and x1 is 0. We have this arrangement there. Now, making mn sort of formula in relationship between the tangents and normal, we discover that our normal gradient is minus 1 over 7. By substituting this value in the equation of the normal, we have minus 1 over 7 is y plus 4 over x, which implies by rearranging the equation, we have y is equal to minus x over 7 plus 4. So the equation of the tangent that we are looking for is y is equal to 7x minus 4, and the equation of the normal to that curve is y is equal to minus x over 7 plus 4. Thank you. Please do not forget to share, subscribe, like, and get in touch with me at Orekoya at yahoo.com or 08055384618. Thank you. You are welcome.